Welcome to the videos that will teach multiplication facts strategies. This is the second video, and it builds on the 2, 4, and 8 multiplication strategies. So today we'll discuss when kids are really proficient with their 2 times table, their 4 times table, their 8 times table. When they've mastered those, and that may take a while, the next strategy is to learn your basic multiplication facts. So the next one you want to look at is a fairly easy one, and the only reason why you use it now is because the next two build on that one. So you want to look at multiplication by 10. And most kids, because you've used place value language in your classroom or with them for a while, they understand the times 10 pretty easily. So if I have 6 times 10, well, most kids would be, okay, well, that's 6 tens, and 6 tens is 60. So they would get this fairly easy. And again, if you did something simpler, like 3 times 10, they would know that that's 30. Okay? So once they're very comfortable, very fluid with that, the next strategy that I would use is the times 9 strategy. And the reason why I teach those together is the thinking involved in doing times 9 resembles the thinking involved in doing times 10. You need to build on what you know when you multiply by 10. When you multiply by 9. Those numbers are close by, meaning that what you're going to do with them is similar. So I would use, again, my same strategy would talk about multiplication as being the area of a rectangle. So what you know when you have 3 times 10 is you build a rectangle that measures 3 on one side and 10 on the other. Okay? So what happens when I change the length of the long side to be just 9? What do I need to do with this rectangle? Well, I need to physically remove one part. But when I remove one part to have 9 as the length of this side, how many have I removed? Well, because I'm multiplying by 3, the side that I'm removing has 3 things in it. So if I know that 3 times 10 is 30, the thinking involved in solving 3 times 9 is just that really it's 30, but I need to take away 3 more for the side that I'm taking away. And 30 minus 3 is fairly easy if you know your partner's 10. You will easily see that that's 27. And that's how you would get your times 9. Okay? As students, one problem they will get with this is they'll want to subtract 9 because they're multiplying by 9, and they get confused with which numbers to subtract. To solve that problem is to get kids to build their rectangles at first when they learn the strategies and remove the one extra side every time. So if they build 10 by 6, well, to have 10 by 6 by 9, they would need to remove one whole side. And they would notice that the side they're removing has 6 in it. So you would have 60 minus 6, which is your 54 for your 6 times 9. So having students play with the concrete materials to really see what's going on when we're multiplying by 9 in comparison to what happens when multiplying by 10, very important. Once kids kind of get straight in their head what happens when you apply by 9, well, then you can let the minutes go and just do the mental part. So again, the strategy is fairly simple. When you think about 7 times 9, what you know is 7 times 10. They're very close in proximity. That's an easy one. Well, if 7 times 10 is 70, 7 times 9, the question could be, is the answer going to be greater or less than 70? Well, it has to be less because I have a rectangle with one side missing, one length of one side missing. So what would that be? Well, it would be 70 minus 7, which is 63, right? If you're 70 and you remove your side that contains 7, you get 60. So all of your multiplication by 9s can be extracted that way. The reason why some tricks don't work is because I don't really want kids to be limited to multiplying by 9. I want kids to extend that understanding to multiplying by 19. When I multiply by 19 any number, if I multiply 5 by 19, I can totally think about 5 times 20. Well, 5 times 20 is fairly easy. That's 100. What am I removing? Well, I'm removing one length of 5. So 5 times 19 must be 95, right? So that same strategy holds to larger numbers that end with 9. When I learn a finger strategy or just that the numbers you add, you need to add to make 9, well, that strategy does not work for these numbers. So you don't want to have kids limited by strategies. You want kids to be able to extend on every strategies they learn for the lifelong learning skill. Grade 5 math is not the important part. Being a math learner forever is the important part. right? So the strategies you teach need to have longevity. And that's why when I do the times 9, I'll look at what I know. What I know is the times 10 and build on that. Right? Multiplying by multiples of 10 is always easy. Multiplying by multiples of 100 is always easy also. So I really want to build on that understanding. So once you're comfortable with multiplying by 9, well, the next strategy that happens, and I'll rewrite it down, the times 10 and the times 5. And again, most kids can figure out why you would go to 5. And you can ask them, why do you think my next strategy is going to be times 5? The answer that you would want to hear is that, well, you know, Miss Roy, the thing that happens when you multiply by 5, 5 is half of 10. So if I know that 3 times 10 is 30, 3 times 5 needs to really be half of that because I'm halving the length of my side. So I should have 2 parts that are equal that make up the 10, made up of 5 and 5, right? And that's a very interesting strategy that most kids at this stage, once they've experienced the rectangles and the areas, could probably come to on their own. So you want to encourage them to make these predictions of what's going to happen when you multiply by 5. So if I have 3 times 10, that's 30. Well, 3 times 5 must be half of 30, right? Here, the interesting part is finding half of numbers that have an odd number in the tens place. Most kids would think that maybe there's no half for that number. So again, you need to look at 30 as 20 and 10. And you can halve 20 to get 10, and you can halve 10 to get 5. So half of 30 must be 15, right? So students who find this part difficult will need a sideline practice of just halving numbers, halving 80, halving 70, halving 50, halving 30. Those will get them very proficient with that. So just a quick review, the 10, 9, and 5 strategies are fairly simple. The 9 strategy builds on the 10 in the sense that it's really close, it's one group less. And the 5 strategy builds on the 10 because it's half of 10. Will be half of the answer that you have for 10. Again, I would practice these strategies in isolation before combining them with the 2, 4, and 8 strategy. So now they would know the multiplication facts for 2, 4, 5, 8, 9, and 10. Right? So the only left will be the 3, 6, and 7, and we'll see this in the next video. Thank you.